Hello, welcome to this tutorial. We are going to look at topic 1 tutorial, units and dimension analysis under chemistry. So these are some very easy concepts, but people find it difficult to do what is correct or what is right. So we'll be using the correct way things are supposed to be done in order to convert whatever that will be given. So in this case, we've been given to convert 25.4 centimeters to meters. Well, seems easy, right? But we're going to use dimension analysis. So 25.4 centimeters, we are saying multiply by 1 meter makes what? 100 centimeters. This is the correct way to do it. All right. I don't want you to be saying 1 meter is equal to 100, then x. No, we are over that now. We use the science standard so that you see how you show how the units are going, and whatever that we're going to remain with, it will be the answer. All right. B. So we have 3.5 hour, right? So this, we know that because the hour is here, we need an hour down here to cancel it. So we need an hour here, 1 hour. How many hours make a second? So how many seconds make an hour? 3,600 seconds. So that and that can go. Whatever that we're going to remain with will give us what? The answer. All right. Our next one is C. So 0.75 liters. So we need to have a liter below here. All right. So 1 liter is equal to how many mils? So 1,000 mils make a liter. So this liter and that liter gone. If we multiply this one by 1,000, we end up having 750 mils. You've seen how easy it is, right? But we do this, not that one where you put your x is equal to what? We are gone past that now. Next question. So we have the pencil length, which is being measured by someone, and it was measured to be 15.2 using a ruler, and the precision of the ruler is actually plus or minus 0.1 centimeters. The question which we need to do here is that we need to report this reading with its precision or with its uncertainty. All right, so how do we report this with its uncertainty? It's very easy. All right, so the length is just equal to 15.2 plus or minus 0.1 centimeters. That's all. We're just reporting. We're doing nothing there. All right. So let's say you've been given this number, all right, 0.250 kg, right, plus or minus 0.001 kilograms. All right. Yeah. How would you find the relative uncertainty? How would you find the relative uncertainty of this? So if you are asked to find the relative uncertainty, or in case you don't know what uncertainty means, it is just the range in which the true value is likely to fall or to lie. All right. So relative uncertainty, anytime we hear the word relative, just means ratio. So we have the absolute, we put the absolute uncertainty there. Okay. Then we divide by the what? The true measure or true value. Then of course express that as a percentage if you want. It's up to you. So the absolute uncertainty in our case is the number here. So we get 0.001 over the true value is 0.250. Then multiply that by what? 100. So relative uncertainty for me is 0.4%. Just like that. All right. Next is, I want us to identify the number of significant figures. All right. Let's say I give you 0.00450 centimeters how many significant figures are in this value? So we need to know the rules for significant figures. Step 1, we know that all the reading zeros are not significant. What are the reading zeros? The zeros that are here are not significant. All right, these are the zeros in front of a non-zero number are not significant. Are we together? Therefore, the only significant numbers are the ones being found at the end there. So here, this one has got 3 significant figures. Next, I'll give you this value, 123.40 grams. How many significant figures are here? Well, here's what you do. A 0 after a non-zero, and that number, if it has got a decimal somewhere, the 0 after a non-zero number is actually significant. This is the 0 I'm talking about. There's a decimal point, and there's a 0 here after a non-zero number, which is 4. This making all of them here significant. So we have 5 significant figures. What about 1000 mils? How many significant figures are here? As long as there's no decimal place, all these are not significant. So here we only have 1 significant figure. 1 significant figure. Okay. So perform the following calculations. All right. So number one is 12.34 centimeters plus 5.6 centimeters. Seems simple, right? But let's add. So when you add this, okay, everything when you add together, all right, to give us the same way we add in numbers. So this will give us 17.94. Is this correct? No, it's not correct. Why? Anytime that you are adding numbers with different significant figures, this one has got how many significant figures? 4. This one has got how many significant figures? 2. You consider the number of decimal places to the small number. So this one has got 2 significant figures, but it has got 1 decimal place, the number at the end there. This one has got 2 numbers at the end, so there are 2 decimal places. So we consider the one with the lowest number of decimal places. So this one has got 1 decimal place, so the final answer must have 1 decimal place. So we round off to 17.9 centimeters. Are we there, okay? Next, 0.0250 liters multiplied by 3.2 mole per liter. I want us to do this. First, we rewrite it into standard form. This will be 0.0250 liters. Okay, multiplied by 3.2 moles over L. Proper now. Per means division. Now that we've done this, we can now just quickly multiply this. You can use the calculator, it's fine. Okay, so I'm going to get a minute. So 0.0250 multiplied by 3.2, I'm getting 0.080. Of course, liter and liter will cancel. I'm going to get moles. But when you are multiplying or dividing, you consider significant figures, not decimal places, all right? So how many significant figures are here? Only 1, 2, 3. So this one has got 3 significant figures. So this one has got 2 significant figures. So our answer, we are going to follow this one. It should have 2 significant figures only. Therefore, looking at what we have here, the same answer is correct because this 0 is not significant, that 0 is not. Only 8 and 0 at the end are significant. So this one is fine. But in the case it wasn't like that, follow the rule which I've told you about. All right. 5.67 grams minus 12.3 grams divided by 2.50 mils. Let us work out this one. So we subtract nicely. Okay, we subtract what nicely? So this gives us 33.37, right? You can confirm with me. So 12.3. So 33.37 grams over 2.50. We are only going to do everything per last. Are we together? We are going to do everything per last. Don't round off here. No, you do everything at the end. So let's divide. If I divide by 2.50, it's giving me 13.348 grams, or this is ml, right? Per ml. Now, let's come here. When dividing, okay, the number here has got 3 significant figures, but it has got yes, and here it has got how many significant figures? 4 significant figures. So we go for the lowest. So our answer must have 3 significant figures. So our final answer is 13.3. If there was 5 here or any number above 5, could have rounded it off, but we don't have, so it ends there. I think the instructions are clear, right? You're welcome.